Yeah, thanks for the introduction. A warm welcome to the audience. Today I have only 10 minutes, so I have to rush a little bit, but you will get the handout later on and use the opportunities. I'm today with you, and I have also two colleagues with me, Johannes Siegert, my AM expert, and Andreas Neumann, who you can also raise questions because they are part of this journey. Okay, today I give you a short overview about our serial application. I give you a short overview of the roadmap we intend to go, and for sure I go on this weight saving in our IM story. So this I will skip due to time constraint. So let's start with our concrete examples of, for me it's a mass production in aerospace. On the left you see the famous lead shaft, so we are producing since a longer time now. And on the right side you see a new baby. This is a dry shaft, so you see it first time as I make it public. It is also, let me say, a kind of high runner, so both parts are kinematic parts out of the R350 door, and in each door, so we have in total 8 doors, each time 2 pieces, so it means for the aerospace also that is a kind of serial and mass production. In total, in the moment we produce up to now 8,000 this kind of shafts, and the highest round about 380, something like this. So it is a good and big part. Good. Then come to our, let me say, our roadmap, our journey we did. So on the top you see our metallic stream. Below you see what we are doing with organic. So what is funny, it was quite, let me say, similar as we started with an idea of an application and took this as a, let me say, journey of success. The key was for me, first of all, that the application, and you see this famous lead shaft, it was really this design for IM. And the success of an integrated team. We started in a kind of multifunctional team. We put people and, let me say, which are burning for this technology together: engineering, qualification people, stress, operation people. And this was really our success of this, let me say, story. So you see, we started in 2017. So this year there will be, let me say, a vision which was set a couple of years ago to say we want to have to establish an AM tech center. And there will be an opening event very soon in October with the CEO, where we have new printers, new metallic printers, and also have the organic printers in one building. You can see it in a small there in the right corner, but it started just to build it up. Okay, so then one important thing is that so I just said that we have a team which are burning for this technology. And we are not waiting, let me say, for the future. We want to influence the future. So you have heard today from Thomas Bielefeld. Also, for sure, we have a lot of regulations, quality aspects, but we want to influence this. And you have seen the lead shaft and the dry shaft, which are not at all critical parts, but we intend, and there is a lot of opportunity also, to go on higher level. So, and this we want to intend also in our journey. And for me, this is also every time important, and I saw today a lot of presentation where everyone is in his own journey, and so I'm every time to make a little bit marketing. We can do it together to accelerate, to give it a boost, because if you are doing it alone, you will maybe not succeed. So be invited also. We are looking for new materials. We are looking for digitalization to avoid, or let me say, to reduce also quality check, etc. So be invited, come to us, and let's see to get a partnership. Good. So now about the weight reduction. Let me say, it is a couple of dependencies which are, let me say, to get a good design of IM. And I mentioned it, this design for IM is really a key enabler to think different. As we started our journey, it was more that we pulled the engineering people to say, hey, we have an application, do you think we can print it, etc. So up to now, we come more and more, and there's a lot of trainings what we are doing with engineers to use this technology. And we have, let me say, a lot of opportunities also what the software is bringing in our daily, let me say, environment. There's a lot of promises about softwares. And so we see, and there's also, I mentioned Johannes, so he is also in the moment to making the jump in the helicopter applications. And it is now more that the engineers pushing us, and this is the right direction. So design for additive manufacturing, I think, so there's tool available. We are also, by the way, we make our own design of support structure. We have heard today that, to avoid support structures, yes, on this we are also working on. And the expertise and know-how, the other pillar, to validate our design. It is also, let me say, we have to use our experience, what we did with our applications we serialized. And there we see of wall thickness, porosity, and this we have to bring also in this, let me say, spirit of weight reduction. Software I just said, so there's a lot of promises. Software available, we use them, we are using a lot. And I heard today from BMW that they are also looking to support more and more the design, you see, and then it is really in an efficient way where you can work for the aerospace. Okay, good. Sustainability. Maybe one information, our powder we producing, so we in Airbus Helicopters, we have, let me say, 80% of the consumed titan powder are we, no one else in the Airbus group, so means we have a big part of this AM powder, and it is really also this that this powder we are buying, this will be to 90% consumed by us. There's only 10% roundabout of waste, let me say. For recycling, for the support structure and so on, there we are also looking for, let me say, a kind of R&D project. It is the sense that in the future that we are using this material, this waste, to reproduce it in powder and then use it again. But you have heard today, it is not at all easy, so we have to take care with our quality, but this is the intention behind. And Other topic is that, yeah, we have short transport ways, because from the post-processing, and believe me, for this shaft you have seen, it is a long story of post-processing. We make high isostatic pressing, and this is the only thing which we are doing outside. Everything what we are doing, clamping, milling, drilling, etching, is all in our facility. And there we have also shorter transport ways. So I see I'm quite before the limit. Conclusion. So for us, industrialization is for us core competence. It is really the end-to-end of the AM story. It is not only the printing, it is not only the design, it's the independencies of all in this long process. The other topic is that what we heard today also is the qualification requirements. This is also a topic where we have to work on, where we have to be efficient. Our topic of safety, you have heard it today, it's also our key. And yeah, last but not least, also this know-how of this design of manufacturing. So for me, it is really the key to get it in a, yeah, let me say, money-making way. And yeah, please take the invitation to contact me, Johannes or Andreas, would be a pleasure. And later on, you have also the opportunity to raise questions. So sorry, Karl-Heinz.
No problem. Thank you, Frank. Okay, so welcome also to my presentation about MTU, how 3D printing contributing to our sustainability challenge. Just have to wait for the slides. Okay, here we are. Yeah, so what is MTU doing to improve sustainability in aviation? First of all, I would give you some key facts about MTU and what we are doing to understand more how we can work on that before going into additive. So MTU key facts. So we have today a revenue of 5.3 billion euros and 11,000 employees worldwide. One key fact is we don't do diesel engines. So this is a part which was split 30 years ago. So we do aero engines. That's how we call it. And a quarter of this is the commercial OEM business that we're working in with our partners Pratt & Whitney and GE. Close to 10% is military business, and 2/3 of all our business are commercial maintenance, repair and overhaul business. So where we use additive is mainly in the commercial and also the military business. So this is something Thomas Bielefeld told us already before lunch. About aviation, we have a typical life cycles of 30 to 40 years. So this makes some things more challenging for us. So we have a return of invest typically after 10 to 15 years, and we have a development phase of 5 to 7 years. So 5 to 7 years, and you have to put your design at the beginning. So this makes it very challenging for us to put new technologies like additive in this. And that's also the reason why we are so slow as we think in implementing this new technology into our engines. And the other challenge we see here, we're talking about reducing our carbon footprint, the climate impact by 2050 to zero. And looking at this makes it even more challenging. And that's what we're working on this as MTU to get to a reduction there. So we are working in 3 main new engine concepts, where we also will use additive in these concepts. So the one is further development of our current geared turbofan engine with further fuel burn reduction. And the next step will be even more, let's say, revolutionary. So we will have a water-enhanced turbofan there This means we will have heat exchanger, and we will recover the water from the engine to further reduce the fuel burn, and which is even more important, to reduce or to eliminate the contrails, which have an impact of more than 50% in our climate impact in the engines. And as mentioned, we're talking here about heat exchangers, so this is starting about getting interesting for additive also. And even more, if we look at the right side, we have the flying fuel cell. So there's a fuel cell and an electric engine to fully reduce or nearly fully reduce the carbon footprint, which is also very interesting for additive. So we want to be ready for these new technologies that we have in the next future. And so that's the journey in the next slide to show you where did we start to get there. Because we are starting there with a different steps. So this was boroscope boss that we implemented 2016 in the A320neo. So we have, meanwhile, including production, more than 8-year experience in production in that part. Even though it's a simple part, but for us it was very important to start production, to learn about production, and that's what we have with these parts, more than 7,000 parts printed, and a very positive field experience. But because that was the intention about this, we also had a lot of learnings with these parts, like how to get to the target cost, the influence of the follow-up process chain, all the inspection, quality assurance. This was all being built up with these parts. And especially at the beginning, we also had high scrap rates. So we started with the 10-year-old machines at that time, and we had to improve the machines, to improve the gas flow and put in online monitoring and things like that. And today we are much better than we were at the beginning, and we have significantly reduced cost and scrap rate. And this was very important for us to set a base to be able to get to the more challenging parts. And one of the outcomes of this was also that we implemented a center of excellence at MTU. So everything about these parts was about establishing production, focus on manufacturing. And in 2018, we reorganized additive at MTU. And since that time, we do have a center of excellence, including a dedicated team for bionic design, which was one of the main learnings that we had there, that we can't do it only with production. And so this is one of our latest parts that we have approved beginning of this year. So this is our first full bionically designed part that we have or will have in the GE9X engine in the 777 Boeing. And we have a new design approach there also, which was damage tolerance, because this is a very highly fatigue-loaded part also. And we saw from this part, doing all this redesign, we had significant reduced machining and end up in a 50% weight reduction. So we see if we really can do bionic design, we can significantly reduce both cost and also weight. So summarizing all of this, looking there, so what was very important for us, we had this new manufacturing process established for the A320neo engine, and this was important to us to really be able to use additive in the very early design phase, because we're sure we have a production manufacturing process ready for this, and not having a conventional backup. Because at the end, the full potential we can only tap if we use the additive right from the beginning in the design phase. And this is very important for us, because now we have the possibility to use lightweight design and even more important, complex functional design in our future engines, because this is exactly what we need there. If we look at the concept, so we need heat exchangers, we need complex casings with internal coolings or temperature control. This is everything what we need in these engines, and so we are sure that additive will play a much more important role in these future engine concepts than we have it today. If it's not only more important, I guess it's even a crucial role, really, to get this flying. So this is a short overview about what we're doing here at MTU. So thank you very much for listening, and I'm looking forward for our discussion.
All right, thank you very much, both of you, for the interesting insights. Yeah, once again, please use the Slido app to raise your questions, rate the questions, the ones you find most interesting, and we're going to look at what kind of questions we can answer at this point. There's the first one already popping in that has a couple of likes here. It's coming from Gregor Reischle, from Gregor. Obviously a question about standards. Which evaluation aspects will require specific AM sustainability standards, as we need to avoid greenwashing and assure accountable, sustainable AM use cases? I think that's the question.
Good question.
Frank, go ahead.
Yeah. So standards we have seen today, and you just mentioned it as well. There's a lot of standard existing in aerospace, and so up to now, I'm not aware about the standard of sustainability. There's a little bit for me that you have also in mind, and you have to have it in your DNA. And I think we are all in this kind of spirit of that we think sustainable, and we try every day to think about. And I don't know, do you know a standard up to now for sustainability?
You mean specific standards in referring to the production itself? Yeah. I don't know that. I don't think that there are standards today, and I'm not sure if we really need specific standards for additive, because at the end we have the same requirements like all the other manufacturing processes. So we have waste, we have energy consumption and everything, and I guess we should look at these standards that we have in production, and we don't need specific things, maybe to some extent, yeah. But at the end, we need to fulfill the same requirements and standards like all the other manufacturing technologies. I wouldn't make a difference there, honestly.
I think the question is also to separate maybe between the manufacturing process of the aircraft and the additive part is just maybe a very small fraction of that versus the lifetime and lifespan of the aircraft itself. So maybe for additive, it's just a very small fraction, so we rather probably need standards for the whole manufacturing process to calculate.
At least today, yeah.
There was also the question about raw materials. I think in titanium, it's not so easy to recycle the material. In some cases, we see powders already on the market that claim that have certain recyclability rates. I think for conventional manufacturing technologies, or for chipping, especially for machining, it's quite difficult to recycle the chips. How do you see the potential there for additive to reduce this carbon footprint in this manufacturing cycle of titanium parts?
So for the raw material, I tried to set it in my presentation. So let me say, the ships we are shipping around the world, and believe me, we are also producing a lot of ships every day. And the intention, and there is the logic behind, to make out of this ship in the future powder, and then to consume it back to additive manufacturing. So for sure is for the aerospace, due to the charge and so on, that it is really in a good manner. But yeah, it is really a good trend for this. And for titanium, what you just said, it is a special market. Titanium is not like you take steel or aluminium, so titanium is a special market. And by the way, we, as I said, 90% of our bought powder we are consuming by our own.
And as I understand right, you are only doing metal titanium right now, predominantly?
Yes, metal, and for sure we are also doing organic, because I saw a question linked if we are doing also structural parts. Non-structural parts we are doing in polymer, and we have in the moment a big screening, let me say, screening on our new programs. We are looking for new helicopters, and there we intend to go also in this step. Also what we are doing with metallic. Yeah.
Okay.
So
Also that MTU?
For us, it's predominantly Inconel 718 powder, but as more or less we're doing similar things like you do, reuse most of the powder, and we have some approaches also to reduce the scrap powder or to reuse it for low critical parts, like in toolings, for example. But at the end, it's metal, and metal is still quite easy to recycle. Guess that's more difficult if you're working with plastics.
Mm-hmm. Where do you see the main driver right now for sustainability in general? Is it coming from the end user of the aircraft, of the helicopter? Is it coming from political standards or political targets that are being set, or where do you see the driver right now for?
So for Airbus, we are pioneer of sustainability. It is our, let me say, our social responsibility of that we think you mentioned 2050. So we are also looking for our carbon footprint. We have so many projects in Airbus. For Airbus Helicopters, we are working on the city Airbus. So there's a lot of running. You mentioned fuel. We're looking for new designs of fuselage, wings, etc. Also, so there's our, let me say, it's also part of our strategy of our company. Yeah.
Yeah. Also for us, at the end, it's coming from our customer. Yeah. But at the end, it's a requirement that we have in society, that we have with the requirement to get aviation climate neutral. So that's the same challenges we all have in aviation. That's the same for us, and everybody has to play its role in there.
Okay, someone is asking at MTU, are you printing the parts internally?
Sorry?
Are you printing the parts internally? Christoph Schrock is asking. Is that something you can share at this point?
Yes. I can share that we are printing them internally, or let's say 90% of the parts we are printing internally. And we have, at MTU, we have 8 machines. It's not only all production, it's tooling and everything that we do, but the focus is on internal production.
Okay. I think in both of your presentations, we saw 2 different potentials for the lifespan of an aircraft. I think the one was the increase of performance of the turbine mainly, and on the other hand, it was the reduction of weight. Mm-hmm. Which one do you think is the one that's actually more attractive to pursue? Is it reducing weight so much more important to reducing carbon footprint, or improvement of the engine, of the performance of the aircraft?
At the end, both goes together. So if we reduce weight in the engine, we can create more efficiency in the engine, and we reduce the fuel burn. So because every kilo that we have in the engine, we have to put in the air at the end. So the more we get out of there, the more efficiency we have in our aircraft.
I totally share. Maybe to add, so it's this buy-to-fly ratio. What we at this beginning reduced on weight, it brings over the product life cycle management enormous, and this is also where we think in our weight philosophy. But it is, by the way, it should be in a good mode in all areas. But yeah.
Now there's a question about other applications, other areas besides the door where Airbus sees further AM cases. do you have a roadmap in mind where further applications?
Yeah, but I
They come
try to
from.
set it so we have a lot of, let me say, new products in our development, and in the meanwhile, I said it in the presentation that the push-pull mode. In the meanwhile, we are in the ramp-up of the project, let me say, in a dedicated main state, where we are only looking, and our intention is also to make family concepts in our products, to say this is a future IM design. It is not anymore to think in a conventional, in a normal way, let me say. And so we are in a big screening in the moment. And it is not only that we are looking for metal, it is also for polymer. And yeah, it is, as I said, in the moment it will be more and more. I'm happy about, so it was 6 years ago, it was in a different mode.
Now you're both, I would say, one of the premium users of additive manufacturing, I might say, of metal AM, on the forefront of aerospace. When you think about the potential you have cost-wise, sustainability-wise for additive, what would be your expectations from the supply chain to actually enable you to accelerate that speed? You mentioned before it was 2016, I think, the borescope part, so it's a long time ago already, and you taught 2006 it was?
No. So we started production 2014, and the engine is in service since 16.
So you mentioned yourself it took you a long time to further advance from that. So the whole supply chain, probably half of the audience is coming from machine suppliers, material suppliers, software vendors, etc. So what do you think is something that this industry needs to further develop to accelerate the speed of adoption? Maybe some last statement from.
So for me, and I tried to show it in the presentation, and so it's, for me a very important thing is that the printing is one story, and we have the post-processing. But there's this independencies in between, and I had this morning the funny talk with a guy who said, I can support you, that we have a look making pictures in your machine, and then we could avoid later on the computer tomography. So you see, it is a balance of all. So it is material, it is the machine providers, everything. And this is what I mean. We can do it in a booster because there's a lot of opportunities to spend money.
Mm-hmm. I guess we have requirements over the complete process chain. So on the one hand, the machines have to be more industrialized, more productive. So we started our production with the first single laser machines. And now we're getting to multi-laser, but we need more reliability and everything there. And especially as we're talking a lot about designs at the moment, to reduce the design restrictions. So there's something about overhangs, roughness, and things like this. This is giving us very much limitations still in additive when we are talking about complex designs with internal structures, because this is what we need in the future.
Okay, thank you very much. Thank you, Frank. Thank you, Karl-Heinz. Thanks to the audience for the questions. Let's hope that this sustainability hype will not just be another hype that will get less and less over the next couple of years, but it will maintain driving the industry. I think there's a big potential we all saw today in various presentations already, and probably ongoing over the next couple of hours. Thank you very much for this panel. Thanks to you guys.